The sales S in hundreds of units of a seasonal product are modelled by this function here. T is the time in months. Sketch a graph of the sales for a period of 12 months. So I'm going to need some axes for that sketch, like so. And so we'll have T along here, we'll have S up here. Now I can see, looking at it, that the mean line is going to be at 54.8. Let's mark off 6 months, 12 months along here, and then it's probably a good idea to actually graph it if we hadn't already done that. So graph and table. So we're going to put in 54.8, add 32.5 cos, and in there we'll have pi x over 6, and we'll graph that. And then we want to change the axes to fit with what we're doing, so 0 up to 12, and we can take that from 0 to maybe 100. That'll probably look pretty good. So it looks like we've got one complete cycle, and if we do a ycal when x is 0, that gives us 87.3, which is the 54.8 add 32.5. So that's going to be there at 87.3. And of course it will be at the same height over here at 12 because we've got a complete cycle. And then let's find the minimum. And that's at 22.3, which is 54.8 take away 32.5. So that was 22.3, and that happened just here. So all we need to do now is add the shape. So it's going to be something like this. And then we want to use the graph to find the months when sales were greater than 6,800 units. Now remember the hundreds of units we pointed out over here. So what we're looking at is X is 68. So something like that. And let's graph that over here on our calculator. So we'll put both of them on. And then we can go analysis, gsolve, go for the intersection. So we've got one at 2.2 and the other one is at 9.8, and then we just need to look at the months. So up to 2.2 we've got month 1 and 2, so that's January and February. And then from 9.8 onwards we've got 10, 11 and 12, so that's October, November and December.